in case if we are dealing with two variables, xi and yi, and let us suppose under those xi's and yi's variable, if we have certain ties, so if there are large number of ties, then we would have to make correction for the Spearman's rank correlation coefficient. So students, I will be sharing one real life data sets where there were ties in the data. So we would be calculating the Spearman's rank correlation corrected for those ties. The problem in hand is the mathematics and statistics marks for 7 students, they are being taken and we are required to test at 5% level of significance that both of the marks, the mathematics and the statistics marks, they are related to each other. So students, the first thing we need to do is we need to rank these observations from smallest to the largest, and then we would have to calculate Spearman's rank correlation for them. So as far as the procedure for testing hypothesis is concerned, the first step we would have to follow is to formulate the null and the alternative statements. So under H0, we would be considering that x and y are independent. As you have seen under the problem, that we were not given whether this test would be one-tailed or it would be two-tailed. So if it is not mentioned to our students, then we are going to calculate it for two-tailed test. So under H1, we would consider that x and y are either directly or inversely related. Under step 2, which is the level of significance, it is denoted as alpha and it is being mentioned as 5%. Step 3 is test statistic. So following correction may be used in case we have number of ties in our x and y observations. So these are the list of formulae that we would have to calculate before interpreting the value of Spearman's rank correlation. As far as the calculations is concerned, students, first thing we need to do is to find out the ranks of x and ranks of y. Now we have assigned the rank of 1 to the most minimum value of x, and same with the y. We have assigned the minimum rank of 1 to the most smallest observation under y. If we just observe x, you can see that this 5.5 value and here you can see this 5.5 value, they were being tied to each other. So there must be the similar marks that were being obtained by the students, and we have assigned the average of the two ranks to these students. So as you can see, this is the rank 1, then 2, then 3, this must be 4, and this is 5, 4, 5 and then 6. So 5 and 6 ka jab aap average lete hain, that will give you 5.5. So that 5.5 rank is being assigned to both of the observations which were tied. As far as the ranks of y is concerned, as you can see that we have two set of ties here. One is present here, which is being assigned a rank of 2.5, which is the average rank we have assigned. So students, yahan pe there must be, as far as ranks were being concerned, the rank of 2 was assigned to this value and rank of 3 was assigned to this value. As both of the observations were identical, so we took the average of the two ranks and we have assigned 2.5 each to these two observations. Now when we move forward, then we can see that these three observations, they were identical. So our rank of 4 was assigned to this value, 5 to this and 6 to this value. And then by taking the average of these three, we have assigned a rank of 5 to all these three observations which were identical. The next thing we need to calculate is DI. That is the difference between YI and XI ranks. So 1 minus 1 gives us 0, 2.5 minus 4 gives us 1.5 and so on. 5 minus 3, that gives us minus 2. The next thing according to the formula we need to calculate is DI square. 0 square is 0, 1.5 square is 2.25, so on, minus 2 square would be positive 4. Now summing over this row of DI square, we got the sum as 44.5. Now we'll be making use of all these calculations we have made and we'll be calculating these formulae. The first thing we need to calculate is Tx. Students, x में देखिए हमारे पास सिर्फ दो observations tied थी. So according to the formulae, this T stands for number of times they are repeating. So 2 cube minus 2 divided by 12, that will be 0.5. Ty1 is to be calculated for the first two observations which were tied, as they were appearing twice, so 2q minus 2 by 12. And then if we look into the next three observations, they were appearing 3 times. So 3q minus 3 by 12, that gives us 2. Now summation x square is being calculating using this formula. That gives us 27.5. Plugging all the information under summation y square formula, we have got 25.5. Further, in order to calculate RS, plugging all the values of summation x square plus summation y square, summation minus summation d square over 2 under root of summation x square, summation y square, that gives us a value of 0.16. So this is a calculated value under Spearman's rank correlation coefficient. Now student, as you know that this was a two-tailed test, so I've shared a portion of the Spearman's rank table under two-tailed test. The critical region or the rejection region is that we need to reject H0 if our calculated value of RS is greater than the tabulated value. So for n equal to 7 and alpha 0.05, the table value is 0.786. As you can observe that the calculated value of Spearman's rank correlation, which is 0.16, is less than our tabulated value, 0.786. Therefore, H0 will be accepted, and we can conclude that the marks obtained in mathematics and statistics are independent of each other.